All right, hello everybody. Today we're going to be talking about special triangles. Namely, we're going to look at details for a 45, 45, 90 degree triangle and a 30, 60, 90 degree triangle. Okay. The first thing that you need to understand about a 45, 45, 90 is that the two sides, which we call legs, are the same. So this is the same as this. But then, how does that affect the hypotenuse? Well, all that means is that the hypotenuse is going to be the same length, x, with an additional square root of 2 attached to it. Similarly, if I look at the 30, 60, 90 degree triangle, I will always begin with the short side. That's going to be called x. If I then compare that to the hypotenuse, it turns out that that is the same measurement as x multiplied by 2. So this is twice the size. When I look at the remaining piece, I keep the x with an additional square root of 3. And those are basically the simple relations between both of these triangles. Okay. Now, with that in mind, I'm going to go to what I consider to be a level 1 question for a 45, 45, 90. Okay, so imagine for a second that I have my original triangle. So if all of a sudden I change it to this, then I claim I can figure out the missing piece. Okay, so let's double check. First thing I know is that these two sides are the same. So suppose that I call them both 5. That is enough for me to figure out the leftover side, as long as I realize that it's the same number with an additional square root of 2. That means, therefore, that my answer here should be 5 square root of 2. And that's it. That's the only thing I have to say about that particular section. Okay, so I'll notice that since this is 5, this is 5, so I keep the 5 with an additional square root of 2. Okay. Moving on, if I now take a look at the next example, suppose that I'm told that my answer is already 3 square root of 2, then all I have to realize is that when I have that x value with a square root of 2 next to it, then the other sides are just the original value, the 3 in this case. So that means I already know this measurement and this measurement. Since I have the 3 and an additional square root of 2, all that means is that this must be 3 and this must be 3. Nice and simple. If I look at a level 1 question for a 30, 60, 90 degree triangle, I just have to understand that all of my decisions are based on the short side. X is the short side. When I look at the hypotenuse, I have to understand that this is twice the size. And when I look at the other section, it's the original x with an additional square root of 3. So if I say that this is 7, I claim I have enough information for the other two sides. And it'll be like this. The hypotenuse is going to be twice the size of the original. That makes this 14. On the other side, it's going to be the original 7 with an additional square root of 3. And that's my answer. Simple, as long as I know the value of the short side. When I look at the next example, they're trying to trick me here in that they are giving me the value of the hypotenuse, but I know that this is nothing more than twice the value So if that's the case, I can only have a 10 if that's originally a 2 times 5. But then that means that the small side here must be the original 5, so that this is now twice the size. And on the other side, I have to keep the 5 with an additional square root of 3. And now I have both answers. Okay. So at this point in time, I'm going to move into what I'm going to refer to as my level 2. Okay. Now, in this kind of a question, let's kind of zoom into this section. In here, I want to show that basically my skill is to try to rationalize the denominator. The denominator is here. And so really what I'm saying is I don't want the denominator. It cannot have this symbol. So in order for me to solve that, I just have to figure out how to get rid of that symbol. Okay. So taking a look at my work here, I am basically going to go ahead and I am multiplying this, my original question. I am basically multiplying it by a big, giant 1. Except that the 1 that I choose has a special property. It has to be the same as my original denominator. When I multiply this, I will multiply it by going top to top, bottom to bottom. So on the top, I end up with 5 times square root of 3. And in the bottom, I conveniently put them together so that I can find the base. And at this point in time, my answer is now 5 square root of 3 over 3. Taking this example, I can now go ahead and solve the following question. So this becomes 6 over square root of 3 times, remember that's that big 1 that I'm going to make, keep the 3, both on top and on bottom. I'm going to multiply top to top, bottom to bottom. And the cool thing is that on the top, I am left with just these 2 pieces next to each other. On the bottom, I conveniently have a perfect square. Here I can say that I have my base, and my final answer turns into 6 square root of 3 all over 3. Now I realize that 3 and 6 are related, so I can divide 6 by 3. So this goes in here twice, into itself once. So I can now claim that my final answer is in fact 2 square root of 3. Okay. Now, how does that compare with the problem next to it? Well, it's basically the same thing. The only difference is that now my denominator is a square root of 2. But my steps won't change. My numbers change, but not my steps. So in here I'm going to write that this is 7 square root of 2 times, and now I strategically pick the same number, square root of 2, square root of 2. They have to match. I'm now going to multiply top, multiply bottom, and I end up with 7 square root of 2 all over my perfect square, 2 times 2. Again, I notice that this is now a base. Final answer turns into 7 square root of 2 all over 2. Since 7 and 2 don't go into each other evenly, I leave the answer in this form. There's no need to do anything with it. Okay? So, now, keep in mind that this is what I call my skill. So what I'm going to attempt to do is to take the skill and to now put it into practice. And all that really means is that if I'm given a triangle, like the original, So if I now say that I know this about the triangle, then I'm claiming I can figure out the value of the leftover pieces. Okay, so let's see how that would work. Okay, so first and foremost, let's adjust this. Go. I'm going to start by saying that this is the same as this. In other words, these two pieces are equal to each other. If that is true, then my goal is to figure out how much x is. Well, that's easy. All I have to do is basically rewrite the problem like this. X square root of 2 is equal to 6. And I am solving for x. So let me put it in here. I am solving for x. In order to do that, I'm going to now divide both sides by the square root of 2. And so that now gives me that x must be equal to 6 over square root of 2. But I just learned from my skills section that I'm not allowed to have a square root of 2 in the bottom. So that's easy to fix. Multiply this by square root of 2, square root of 2. I'm going to multiply the top, multiply the bottom, and I end up with 6 square root of 2. And at the bottom, 2 times 2. This produces the base. So now I'm left with 6 square root of 2 all over 2. Since 6 and 2 are divisible into each other, this way, I can now claim that I have 3 square root of 2. My conclusion is that x must be 3 square root of 2. Well, the good thing about that is that now I can go in here and say that this, therefore, is 3 square root of 2. Sorry, 2. And this is 3 square root of 2. And it simply matches my answer from the work I just did. Again, take a look. I am putting into place my skills from the top and adapting it to this problem. Okay. Second skill. Suppose I now say that I have something where x is equal to 8 square root of 3. Then how much is it if I have x times another square root of 3? So here's the trick. X is this much. So what I'm really doing is I am using this idea called substitution. Where I am going to replace x with the number. But I already had a square root of 3, so I just bring that square root of 3 down. As soon as I see that I have 2 square roots of 3, I can now put into effect the idea of creating a base. And last step, 8 times 3 is now 24. Now that's the skill. How do you put that into play? How do you put that into the actual problem? Well, let's set it up like this. So what happens is that here, right, if I now claim that I have this triangle, and so if I now have a triangle that now looks like this, then I can figure out each of these leftover pieces. That's what I'm claiming. Now, what that means is that in this situation, x is going to match with this, and these are equal to each other. So if this is x, then that means that this one must be the same as x times square root of 2. But then all that means is I can replace x with 4 square root of 2. So what do I have? I have x is equal to 4 square root of 2. So then x times square root of 2, replace the x with 4 square root of 2, because after all, this is what I know, times the extra square root of 2. Now, here, I basically have 4 times a perfect square, which happens to be 2 times 2. So all in all, at the end, I end up having 4 times 2 for a final answer of 8. Conclusion is that x must be 8. So that means that the hypotenuse is equal to 8. Now notice that because this is a 45, 45, 90, the other side must be the same size. So 4 square root of 2. So that one's not very difficult. That one's just repeated. Okay? And that is all.